Hello everyone. So chapter 1 has been quite long, I can understand that. So finally I'm saying that this is the last lecture for chapter 1. Here we are going to study three distribution, ideally three type of distribution. One is known as geometric. The second is known as negative binomial distribution. And the third is known as hypergeometric. So with respect to all these three distributions, we're going to see something which is very, you can say, different than rest of the distribution. Within each distribution, it has been divided into two types, okay? But hypergeometric is like a single one. All these three distribution are nothing but a discrete type of distribution. Therefore, it's not like a traditional continuous distribution which we have been doing till today. Okay, now we are moving to again discrete. But why did I choose that towards the end? I choose it toward the end because of its unique property of distributing into two sections. That's one thing. And second thing, the interlink between the geometric and your binomial forming into a hypergeometric, the reason for the distributions and so on. So these are the main reasons why I choose towards the end. This lecture is going to be an interesting lecture, I could say. But you must remember that the questions, okay, these are not important distribution as compared to other distribution done till today. That's what my another reason for taking it towards the end, because like towards the end, people tend to, or the students tend to skip out few things. Here in this, I would not say to skip out, but these are less important distributions. Therefore, I kept it towards the end so that we can do it towards the end and just get that done. So, what we are going to model, the main purpose of modeling in these type of distribution is nothing but success and failure, like your binomial distribution. So, under your binomial distribution, you are seeing collectively as a whole. Here, you will see it individually. How? I'm going to let you know. So without wasting any time, let's jump on to the distribution sector. So geometric distribution. So the first type, okay, is nothing but okay. What is our experiment? Our ideal experiment is perform independent and identical Bernoulli trials. Okay. So Bernoulli trials, whether it is a success or your failure, is nothing but known as your geometric distribution or your Bernoulli distribution. So what do we do? X follows geometric distribution with parameter P. This is nothing but your type 1. Within type 1, okay, we are going to see X as the number of trials until first success. So what do you mean by this and what different it is from other distributions, okay? So here you are analyzing when you will get your success. So you are asked a probability that what is the probability that after seventh success, that is after seventh is nothing but your eighth success, you get your first success. मतलब first after seventh trial or your eighth trial you get your first success. तो पहले 7 ट्रायल में तुम लोग का फॉल्स हो गया and then you get your success. So here you're modeling with respect to a particular success. Okay, in your binomial distribution, you are seeing collectively as a whole. 500 trials में से 300 हो सकता है. Okay, out of 500 trials, 300 trials are possible successes. Okay, we are seeing collectively as a whole. Here we are seeing as an individual probabilistic single value. So what do you mean by this? When you receive your first success. So let me give you an example. Okay. I'll give you a real life example. Dhirubhai Ambani was working in a petrol pump. He tried multiple businesses. The first business that went success was suppose, I do not know the exact numbers, okay, but was suppose the 20th business, okay. So your first success is at 20th after starting 19 businesses, that is your 20th business. What is the probability of that? What is the probability of you getting the first success after starting two businesses itself? So it's nothing but modeling with respect to one success, okay? So the PDF of this is nothing but q raised to x minus 1, p raised to 1, okay? And x can go from 1, 2, 3 to infinity. So as previously, okay, let's calculate the values, okay? That is nothing but your moments, expectation of x. Expectation of x is nothing but sum of x into p of x ranging from 1 to infinity. So this would be summation of x is equal to 1 to infinity, x into p of x. What is p of x? Q raised to x minus 1 into p. As you can see, p I can take it out. There is no need for that. So I'm left with p. Summation of x is equal to 1 to infinity, x into q, x minus 1. Okay? Let me expand this. I'll get this as nothing but 1 into q raised to 0. 1 into q raised to 0. 1 into q raised to 2 minus 1 is 1. Okay? Sorry, 2. 3 into q raised to 3 minus 1 is 2. 4 q cube, so on till infinity. Let me write this in a simplified format. So this is nothing but 1 plus 2q plus 3q square plus 4q cube, so on till infinity. So how do I model this? Okay. So if you open your tables book, okay, tables book. Wait, I'm not getting my tables book. Give me 1 second. I'll just, yeah, it's here. So if you open your tables book and see this, okay, see this, okay. So with respect to this formula, in case if you put x is equal to minus q, x is equal to minus q, and p as equal to minus 2, in that case, what will happen? So this would be 1 plus minus 2 into minus q plus minus 2 into minus 2 minus 1 upon 2 factorial into q x square, which is minus q square, so q square plus p. P is nothing but minus 2. Minus 2 minus 1 is minus 3. Minus 3 and minus 2. So minus 2 and minus 2. P is 2 minus 2, that's why. So minus 2 minus 2 minus 4 upon 3 factorial multiplied by minus q the whole cube. And let me do it for 3 terms now. We'll see that 1 plus 2q minus minus plus 2 into q is 2q. 2 factorial is 2. So 2 and 2 gets cancelled. Minus 1 into minus 3. It's nothing but positive 3. 3q square. This will become 3 factorial is nothing but 3 into 2. So this cut. So I'm left with minus 4 into minus. So plus 4 into minus. So minus 4 multiplied by minus q cube. So minus minus positive. So 4 cube and so on till infinity. So if you see this equation, when x is equal to minus q and p is equal to minus 2, in that case is exactly same as this. So can I write this equation as nothing but p into 1 plus x. What is x? X is nothing but minus q. 1 minus q raised to p, which is minus 2. Simplify. 1 minus q क्या होता है? p. So p into p raised to minus 2, which is nothing but p upon p square, which is 1 by p. So your expectation of x is 1 by p. Similarly, your variance of x would be nothing but q by p square. How you can solve this? You can try this on your own. I'm not doing this solving. Okay, how you can do this? First, calculate expectation of x square in the similar format as this. Then use your simple formula, expectation of x square minus expectation of x, the whole square. The basic formula, and you will be good to go. So this is how you can solve this. I'm not solving this because the proof is not important. Okay. So yeah, this was type 1. Remember, type 1 is nothing but number of trials till first success. Now we'll study type 2. Type 2. Type 2 is nothing but denoted by y. Y is nothing but number of trials. Okay, or you can say number of failures in a trial. So in a trial, number of failures before your first success. So logically, if there are x number of trials, okay, y, then there would be y number of failures and one success will be nothing but total. This is nothing but your total trials. Y is your failures, and there is one success. So after all this attempt, okay, after all so many trials, you get only success once. Okay, this is a you can say not national, but a natural business instinct. Okay, that you do not succeed in your first business every time. Okay, it's your 10th business or the 12th business which goes boom. Okay, you make n number of mistakes, you go bankrupt, you again stand up. So that's why this is nothing but used to model that, your geometric. In X number of trials, so suppose in 15 businesses you have started, 14 business went bankrupt, the 15th business which you started boomed. So this is nothing but a relationship between your type 1 and type 2. X is equal to y plus 1. We are modeling failures, okay? Here we model success, the first success, okay? The first success written here. Here we are modeling failure. So we are interested in y. Y is nothing but x minus 1. Okay. So if you carefully see, there was one success and number of failures. Okay. So here also your PDF would be q raised to y, because you are making y failures and then there is one success. So whenever the question is with respect to failures, what is the probability of you successing after 10 failures, then you use your type 2. If you're asked what is the probability of one success, okay, then you calculate type 1. Understand the clear difference, okay? There would be a clear mention of failure after 10 failures, after 12 failures. Here, what is the probability of first success? What is the probability that after 10 failure you will get one success? So whenever the failure word comes into picture, you need to consider type 2 of your geometric distribution. Okay. So this is your PDF according to your common sense as well. कि y times failure हुआ फिर एक success हुआ. Okay. Your expectation of x. What was the relationship between x? X is nothing but, okay, or you can say you want expectation of y. What was the relationship between y? Y is nothing but x minus 1. So expectation of x minus 1. We got the expectation of x in the above step. It was 1 by p. So this would be nothing but 1 by p. Or you can say expectation of x minus 1, because expectation of a constant is a constant itself. Expectation of x is 1 by p minus 1. P common ले लेता हूँ 1 minus p upon p. 1 minus p is nothing but q. So q upon p. Our expectation of y is q upon p. Failure होने का probability out of the success is q by p. Common sense है ना, ratio of your failure upon your success is nothing but your expectation of your failures, na. Common sense. Then your variance of y. Variance of y is again variance of x minus 1 according to the relationship. Variance of a constant is 0. So this is variance of x. And variance of x, we just wrote it here. It's q by p square. So done. That's it. We are done with the first distribution. Simple, right? You understand why each distribution is getting used. That is the most important thing that you need to consider. That is nothing but why a distribution is getting used. So I try to focus on that point as well. So moving to the second type of distribution, it is like a second step, okay? Let me just write the name of the distribution first. It's the negative binomial distribution. Okay. So this distribution is nothing but an extension of your geometric distribution. So what do you mean by an extension? Wait. Yep. I was not able to draw a straight line. So how do you denote? You denote x follows a negative binomial distribution with the parameter k comma p. So every time you don't model your first success, you want 10 successes. Suppose you're modeling how many times a cricketer hits 6. Okay. So you want 10 sixes in like 50 balls, 70 balls. So you want with respect to multiple sixes, not with a single six. Single six doesn't win your matches, okay? Ideally catches win your matches, but irrespective. 6 maro to bhi game jeet sakte ho tum log. So with respect to 10 sixes, you have won the game. There has been statistical proven properties ki if you hit 20 sixes in like 10 over, you win the game 100%. Suppose, okay, it's an hypothetical example. Please understand where I'm going through. So it's not necessary to model only one success or that point. So we have increased the scope of your geometric distribution into k number of successes. Okay. So your type 1, your experiment, what would be your experiment? Your experiment would be perform independent. Perform independent and identical Bernoulli trials. Okay. And what is your type 1? Your type 1, which is x, is number of trials until kth success. So if you carefully look at the parameters as well, here only probability was considered. Here two things, the number of successes you want and the probability. So it's nothing but an extension of your geometric distribution. So what is its PDF? PDF of P of x. It's nothing but x minus 1, choose function, x minus 1 c k minus 1, p raised to x, q raised to x minus k. K is the number of successes. Okay. Or this formula can be written as x minus 1 c x minus k p raised to x q raised to x minus 1. These are the two probability values which it can take. The expectation is nothing but k upon p. The variance is nothing but kq by p. Simply, see, You had 1 by P, you had 1 by P, you had Q by P. We just multiplied by K. That's it. K by P, Q by P. Because we want K successes. This was for one success. One success का expectation आया तुम लोग को 2 by 5. So 10 successes क्या क्या होगा? 10 into 2 by 5. Or you can say 2 by 5 10 times, which is nothing but 10 into 2 by 5 now. Or you can say KP. K is nothing but your number of successes. You just simply multiply it. It's as simple as that. Okay. Your type 2. Again, similar to your geometric distribution. Okay. Y would be, यहाँ पे x minus 1 था, but now you are modeling successes. K number of successes, not one success. तो ये क्या हो जाएगा? X minus K. What was Y? Y was nothing but number of failures until kth success. So the question is, how many balls did the batsman miss or hit a 4 or hit a 1 or hit a 2 till it attains 10 successes? 40 balls, 50 balls, 60 balls, whatever the number of failures are. Okay. So that's it. What would be its PDF or P of Y? It would be nothing but Y plus K plus 1, C of K minus 1, P raised to K, Q raised to Y ranging from 0, 1, 2 to infinity. Remember the PDF which I have written for NBD is not important. NBD might get asked in your R exam, but PDF won't be important, so do not worry. Your expectation of Y, it's nothing but expectation of X minus K. Expectation of X minus K. What is X? X is nothing but K upon P minus K, which would be nothing but K minus KP upon P. Common denominator कर लिया. K common ले लो. 1 minus P upon P. 1 minus P is nothing but Q. KQ upon P. Your variance of X or variance of Y is nothing but variance of X minus K. K is a constant. Variance of a constant is 0. So variance of X, which is nothing but KQ upon P square. That's it. Done. Complete. That was with respect to a negative binomial distribution. We move on to the last distribution, and then I've kept a few sums for you guys. As you can see here, 3 sums. So first, let us complete the concept because I just don't want to get into sums and then go back to concept again. So what we'll do, we'll complete the concept first. Okay, that is, this is the last distribution. We'll understand how to do it. We'll write some formulas and that's it. Done, complete. So let me write it down. The third and the final distribution of your chapter 1. Okay, hypergeometric distribution. So what is the purpose of hypergeometric distribution? Okay, so how do you denote first? X follows hypergeometric distribution with 3 parameters: capital N, capital N, capital N, capital M, small n. It would be too confusing, right? So let me just divide it into so that you understand what we are doing. So here, X is nothing but number of successes. Number of success in a sample size. Your capital N basically denotes let's not go to capital N, let's do capital M. Your capital M denotes nothing but number of successes. Okay, your sample size is denoted by a small n. the number of failures. Okay, your failure is nothing but n minus m. Okay, so this is how you write it. So why did we do this? Why did we complicate out things? Okay, uh, let's understand the limitation of your binomial distribution, and then we'll understand why hypergeometric distribution is getting used. Okay. Uh, so here, even this what we did was not important, but let me understand you why did we do this? Okay. Hyper binomial distribution, what is our assumption? It is nothing but the sample size is nothing but independent and identical. But for a hypergeometric distribution, they are neither independent, they are not independent, they are not identical, and can be done without replacement. So what do you mean by this? Let me give you a simple example. Suppose you are building a vaccine, coronavirus vaccine. Under your coronavirus vaccine, one time you have made a trial. Okay, if you made a vaccine after investing 100 crores, you made a vaccine, it got failed. You studied that vaccine, you identified 5 reasons why it got failed. Then you developed your second vaccine. Do you agree that the probability of vaccine being success in your first vaccine and the second vaccine is different, right? Because second vaccine, from your first vaccine, you understood the deficiencies it had. You tried to correct it and develop the second vaccine. So the second vaccine being a success, okay, is nothing but higher. The probability is higher. So like this. So there are several cases where you cannot assume that the probability is same. It is independent. पहला में जो करोगे, दूसरे में जो करोगे, it won't be same. No, it's not that. So therefore, in some cases, you will understand it is not independent and not identical. However, hypergeometric distributions के hardly sums पूछे जाते हैं, but it's in our portion, so we'll study it out in case if it gets asked. Okay. So in last 20 years, not a single sum of hypergeometric distribution was asked. So you can understand the importance of it. But again, so what would be its PDF? PDF is nothing but capital MCX multiplied by n minus m Cn minus x upon capital NCn. So when I will just write down 2 cases which are important. So this is the only formula which we have to learn with respect to hypergeometric distribution. With this, the distribution is done, but I want to discuss 2 important sections with you. One is nothing but approximation. Approximation of hypergeometric distribution into your binomial. So ideally, if x follows hypergeometric distribution with parameter m, n, and small n, your n is the sample size, right? Similarly, x follows binomial with parameter n and p. N here also is sample size. The probability p is nothing but m upon n. And here the probability p, okay, is nothing but denoted as probability. So these two are equal. These two are equal when your p, okay, is nothing but m upon 2. Okay, or you can say, you can write a hypergeometric distribution, okay, into your binomial distribution while writing p is m upon 2. तो यू कैन से तुम लोग का हाइपरजोमेट्रिक डिस्ट्रीब्यूशन दिया है तो भी तुम लोग को कैलकुलेशन बाइनोमियल डिस्ट्रीब्यूशन से करना है तो n इसका है वो उसका का वो ही रखो so whatever the n is keep that as it is but probability p instead of writing m upon n, write m upon 2. This would be a close approximation of your hypergeometric distribution and your binomial distribution. That's one thing I wanted to discuss. Second thing I wanted to discuss is binomial approximation. Approximation of binomial into Poisson. So if your binomial distribution, if your x follows binomial distribution with parameter n and p, if your n is quite large, okay, if your n is quite large, so when I say large, n is greater than 200, and your p is quite small, what do I define small? It's a subjective term. So p is close to 0, means 0.01. In that case, you can convert this binomial distribution into your Poisson distribution with parameter lambda, where lambda is nothing but n into p. Okay, we'll see a few sums with respect to these approximation and your negative binomial, so you will understand in a better way. Okay, so let's start with it without wasting any time. So this is the first question I picked out. So there are 55 million people. How many people are there? There are 55 million people. Within that 55 million people, in a UK, independently has a probability of 10 raised to minus 8. Has a probability of 10 raised to minus 8 of being killed by a falling meteoroid in a given year. तो मतलब एक meteoroid गिरा, उसमें 55 million में से एक जन मरने का probability is 1 into 10 raised to minus 8. So it's a small probability. You would agree to me on this point, right? It's a small probability. So n is quite large, probability is quite small. Can I convert this into a binomial? Yes. So your n is 55 million. 55 million. P is 10 raised to minus 8. 10 raised to minus 8. So I can convert this into lambda, which is nothing but n into p. If I just use my calculator, it would be 0.55. Now you have asked, calculate that the probability of exactly 2 death occurs. So probability x is equal to 2. X is equal to 2. You know your lambda. You know x follows your Poisson with parameter lambda. So it would be e raised to minus lambda, lambda raised to x upon x factorial. The PDF of your Poisson distribution, lambda is 0.55, e raised to minus 0.55, 0.55 raised to 2 upon 2 factorial. So I just put this in your calculator. Let me just do that for you. Yep. So it is e raised to minus lambda, lambda raised to x, which is 2, upon 2 factorial, which is nothing but 2 itself. So it's 0.0872. That's it. That's your answer. Complete. Easy, right? So if your n is quite large and p is quite small, you can convert your binomial distribution into your Poisson distribution. Remember this. Moving to second question now. If a probability that a person will believe a rumor about a scandal is 0.8. So there is a rumor about a scandal which is going on. The probability is nothing but 0.8. In that case, calculate the probability that the 9th person to hear the rumor will be the 4th person to believe. So the number of successes in this case, okay, is nothing but 4. So k is equal to 4. Number of people, total number of trials kitne hai? 9. So x is 9. Okay. And the probability is 0.8. What do I use? I use number of successes. You have to model your successes. So type 1 negative binomial distribution. So its PDF is nothing but what is its PDF? Let me just copy paste it. This is its PDF. So let me just write it down. Wait, I'll just copy paste this or this, and then we'll just send it. Okay, the PDF formula, I've copy pasted it here. Oopsie. Wait, I have to bring this down now. Brought it down here. Okay. So you can use either of this formula. So that's completely your choice. But I would recommend using one of the formulas. Okay, which is nothing but this formula, because we have kth number of success and not one successes. So we'll remove this out. So x minus 1, x8, c, k minus 1, 3, 4 minus 1 is 3, p is nothing but 0.8 raised to x is nothing but 9. Okay, p raised to k, sorry, my bad. 0.8 raised to 4 and q raised to x minus k. So q is 0.2 raised to x minus k, which is 9 minus 4, which is 5. Just one small correction. Okay, this is nothing but k raised to k, not x. And it makes logical sense. K number of success, so like k to hona hi chahiye. We wrote k here, but we forgot to write it here. Lol. So anyway, leave it. Okay, just input this in your calculator, you get your value. So it's 0.8. C is shift and C. It's not 0.8, it's 8, sorry. 8C3 multiplied by 0.8 raised to 4 multiplied by 0.2 raised to 5, which is 0.7168. But that's it. That's your answer. 0.2 raised to 5. Oh, it's a small number. 0.0074. 734. 734, yes. 10 raised to 3 मतलब 3 decimal आ गए. So 2 zeros and 734. ठीक है, fair enough. Similarly, your last sum. Okay, this is the last sum of your chapter 1. So it's like a relief for you guys. So don't worry. Among 58 people, so total number of people are 58. So capital N is equal to 58. Only 30 has a particular qualification. 30 has a particular qualification. So K is equal to 30. If a 5 of the group, so तुम लोग 5 का sample ले रहे हो. So sample is N, which is 5. This is your population. This is your main data. N comes from your main data. Or you can write it down here. Okay. You can write down here. N comes from your main data. Okay. And small n is nothing but your sample size on which you will calculate your probabilities. Okay. So understand this. So capital N is 58. K is 30 is nothing but 30 has a particular qualification. So your successes. 5 of the group has been selected on random. So tum log ka sample size is 5. For a survey of a job application, determine the probability none of the group have qualification. Exactly. So you want to calculate that none of the group have qualification. Okay. So your probability. First, let's calculate your probability. Wait. let me just bring this out here, the formula, and then we'll calculate so that it makes easier to understand. Okay. This is nothing but your formula. Okay. This is your formula, right? So you have to model that there are zero individual has your qualification. So x is equal to 0. The probability or your P, let's calculate the probability. Nothing but MCX M. M is nothing but 30. K, or you can even write this as M, okay? M is nothing but 30. CX, X is nothing but 0. N minus M, 58 minus 30, which is 28C. N minus X, so 5 minus X is 0, so 28C5. Upon M is 30, C, and N is 5. I just input this in my calculator and you'll get your direct answer. So you do not have to do anything. Just understand what does it represent. Over the whole population, N is the total number of population you have considered. M is the successes within the whole population. And this is a small sample size within which you will be considering your analysis. So understand the three important things, okay? If you want, you can write this out as well. Okay. 30 C 0 multiplied by 28 C 5 upon 30 C 5. 30 C 5, which gives you the answer of 20 by 29. 30 C 0, 28 C 5, and M this is 50. This is capital N. I read it as N. Sorry, my mistake. NCN. So this is 58. My bad. So this would be nothing but 130 by 6061. Okay, that's your answer with your first part. Binomial approximation. Under your binomial approximation, you consider N as 5 and P as, okay. Okay, if N is large, you can consider your P as M by 2, but it is not large, so we'll consider M by N only, okay. Large means like 1 million, 2 million. In that case, you can consider it. We'll consider as 30 by 58 only. We'll calculate. So P of X equal to 0 is nothing but NCX, so 5C0, P raised to X, P raised to 0, Q raised to N minus X, which is 5. And if you calculate, your answer would be 0.0262. This would be 0.0214. So this would be quite similar. So yeah, with this, we are done with our hypergeometric distribution. In case if you have any queries, do let me know. This was Viraj Shah from the Actual Academy. Hope you have a great day. So bindas message karo in case if you have any queries. After this, you can start solving the assignment question which I give you. You can start solving your text back and so on. So with this, we are done. Thanks a lot. Have a nice day. Bye-bye. So let's do our last sum, which is related to the hypergeometric distribution. We'll understand what does your each factor basically indicates and how do we calculate it. Okay. So before starting, let me just do a quick recap. X is the number of success in a sample size. M is a success in your main data. Okay. That is with respect to the main data on which you will be making your analysis. Okay. N is the total number of samples in your main data. I'll just write it again. Total samples in main data. Okay. And small n is your sample size on which you're making your analysis, and failure is n minus m. Okay. So let's understand this with respect to one example here. It's going to be very easy sum, so please do not worry. So let's start with reading the question. Among the 58 people applying for a job, so total number as per the complete sample size is 58. So capital N is 58. The second factor, only 30 have a particular qualification. 30 capital M. Number of successes in your main distribution is 30. If a group of 5 people are selected in random, so you are selecting a sample size of 5 from your main population in order to do your analysis, are randomly selected for a survey about the job application procedures, determine the probability that none of the groups selected have qualifications. So you want that none of the groups have qualification. यहाँ पे qualification का number है. So 1 exactly. So this can be done using hypergeometric distribution. So probability P of x equal to x is nothing but, let me just copy paste the whole table here. So yeah. So PDF is nothing but MCX, which is equal to 30CX. X is 0. 30C 0 multiplied by n minus m. 58 minus 30, which is 28C n minus x. 5 minus 0 is 5. Upon NCN, 58C small n is 5. So yeah, that's it. Just put this in your calculator and you'll get it done. Wait, I will just open the calculator for your reference. Yeah. So, yep, this is your calculator. It's 30 C0 multiplied by 28 C5 divided by 58 C5 comes out to be 130 by 6061. If you put SND, you'll get your exact value, which is 0.214, 0.02144486. Okay, this was with respect to exact. Using your binomial approximation. Okay, as per your binomial approximation, we can use P as m by 2 when your probability size is very large, but it is not very large. Large is nothing but greater than 500,000. So we'll prefer with this formula only. P is m by n and n is your sample size. So small n is equal to 5. P is capital M by n, which is nothing but 30 by 58. So probability x is equal to 0 would be NCX P raised to x. NCX P raised to x, which is 30 by 58 raised to x. Q raised to, so 1 minus P raised to n minus x. 5 minus 0 is 5. Just put this in your calculator again, you will be done. So this is 5 C0 multiplied by 30 by 58 raised to 0. Anything raised to 0 is 1, but it's okay. I just wrote it. 1 minus 30 divided by 58. 30 divided by 58. The whole raised to 5, which comes out to be 0.02622. If you see the probability numbers, they are quite similar. So therefore, binomial is a good approximation, but there is a difference. Why? The sample size is not large. If the sample size would have been large, your difference would have been reduced. So with this, we are done with chapter 1. Finally, it is towards the end. I want you all to go through the notebook, write this everything, every lecture in the notebook. Make sure you learn your derivations, your formula. Read your textbook, solve the sums in between, learn your summary and solve the text back. Then I'll give you the assignment. You can do that. In case if you have any questions or any part you didn't understand in theoretical concept, okay, please give me a call immediately because it's very important that you know it, or give me a text. I'll help you with that. This was Viraj Shah from the Actual Academy. Hope you have a great day, guys. Bye bye. Have a great day.